So number 8, when we're looking at question number 8, this one has an infinity. Okay, so this is going to be 0 over 1 over 0, and then this is going to be 1 over 0, so this is infinity minus infinity. Okay, we need to rearrange this. We need a ratio, so that although this is indeterminate form, we need to write this as a ratio. So I'm going to write this as a ratio, putting it over a common denominator, and this is going to give me my 0 over 0. Okay, so I'm going to end up with 0 minus 0 over 0 times 0. Okay, so there's my 0 over 0. I have my condition. I can apply L'Hopital's to this. Okay, so this is it's going to get a little bit messy, but it's going to be ln x plus x times 1 over x. That's my product rule, minus the derivative of 1 minus or plus the derivative of 1 is 0. Okay, so the derivative of x is 1, that's derivative is 0. Here we're going to apply product rule, so I get log x plus x minus 1 times 1 over x. Okay, I better simplify this. Okay, that's going to be positive 1 minus 1. So in the numerator I get, in the numerator of this expression, I'm going to get log x plus, well, that's just going to be log x in the numerator. Okay, here I'm going to get log x plus 1 minus 1 over x. Okay, so I'm going to plug in. I'm going to end up with 0 on top. 0, 1 minus 1 is 0. Again, I don't have resolve, but I have the condition to apply L'Hopital's. So I'm going to apply L'Hopital's one more time here. Okay, so knowing my condition is satisfied, I differentiate that to 1 over x. 1 over x, derivative of 1 is 0, minus that becomes negative 1 over x squared. Okay, I'm going to simplify this expression. That's going to be 1 over 1 plus 1 over x. When I plug in, I get 1/2 as my limit. Here I had to apply L'Hopital's 2 times. So this one here, when I look at this, this is kind of a complicated one, but as I plug in, so I'm going to end up with e to the log 2 times, that's going to be log 5 in the numerator. Tan of 0 is 0. Okay, so I am looking at this expression here, and it looks like I have to, because that tan is, this is definitely not an indeterminate form. Okay, because it looks like I'm getting e to the infinity, but I have to be careful here because this is approaching 0, but we need to know which side of 0 we're approaching, because from one side of the angle we're going to be approaching it from the negative. Okay, so tan looks like this. So one side is from negative 0, the other side is positive 0. So let's make this equal to, we're going to approach the 2 from the negative side. That's going to make this negative 0. Okay, and that then makes this e to the negative infinity. Well, this is not anything we need to, this is resolved. We don't need to apply L'Hopital's or anything here, because this is, we can actually evaluate this. This is actually equal to 0. Okay, so that's one thing to make sure that you do is when you have a limit, plug in, check. We don't want to mess around with it if you can actually calculate the limit.